solving quadratic equations by graphing. So this is going to be actually fairly short. We're going to talk about how to solve quadratic equations and what type of solutions we have using graphing forms only right now. So what does this mean? Well, what it means is we're going to get our equation and we're going to set the y value equal to 0. Right? So we're going to set the y equal to 0. That's how we solve. Remember how we said y equal to 0? That's the x-intercept. So x-intercepts are what we call solutions to a quadratic equation. Right? So if I gave you like 2x squared plus 3x minus 5 equals 0, that's where the y was supposed to be. So it's a y-intercept. Sorry, it's an x-intercept. You said y equals 0, it's a y-intercept. So x-intercepts are solutions. There's actually other names for them also. They're also known as zeros because you're setting the x value, the y value equal to 0. And they're also known as roots. And roots are real solutions. So I'll talk about this more later, but x-intercept solutions, zeros, roots are all the same thing when we're talking about real solutions. When we're talking about real solutions, they're all the same thing. So let's talk about a couple types of problems we can have. So remember, we're looking for the x-intercepts, right? So you can have one x-intercept. In that case, we have one real solution. This is also what's known as a double root. The reason it's called that is because you get that when you have the same, like you have two of the same answers. You have like x equals 3 and 3, or x minus 3 squared is your answer. You get the same answer twice, so that's why it kind of bounces off the graph. It's called a double root. And then you can have the normal one, two real solutions, where you cross your x-intercept twice, so 2 real. And then you can have no solution. What if you don't cross x-intercept at all? Then you have no real solutions. So you can have one real solution, which is known as a double root. You can have 2 real solutions or 1 real solution. So on this type, in this example, they want you to use a related graph of each equation to determine its solutions. Like how many solutions does it have? So look at this first one here. It's kind of hard to see the xy grid. It's right here. Here's my x-axis. Here's my y-axis. Over here it's like this. And over here it's like this. That's a bad y-axis. Anyway, we want to tell me what type of solutions do we have and where are they? Where are they? So here I have no x-intercept, so I have no real solutions here. Right, so no x-intercept, no real solutions. Over here I have 2 x-intercepts. So I have two real solutions. And they're at 5 and -2. That's where they cross. Over here I only have 1 real solution, and it's at 1, 2, 3, 4. So I have 1 real. It's a double root. And it happens at x equals -4. So that's how you could tell by graphing. If I give you a graph, that's how you could tell. What if I don't give you a graph? What if I want you to graph it yourself? Well, I'm going to show you this in your calculator. So what we're going to do is here, we're going to graph this one into our equation. So let me show you. So let's come and calculate out again. So it's on. We go to y equals. Let's type in our new equation. So x squared plus 8x. I'm going to graph it. Now, remember last time I did this, if you can remember, I had to fix my window again. This is like zoom fit. Let me go to zoom standard. So you have a graph now. So if you want to see the solutions, you kind of count it here, but let me show them the calculator way. So we're going to go second calculator, and we want the 0, right? The x-intercept is 0, so you go to 0. And it works just like finding the minimax. So let's say I want to find the 0 right here. I'm going to go a little left of it, left bound. I'm going to go back to where I think the 0 is. I'm going to go a little right of it, right bound. And it's searching between my 2 bounds to give me the answer. In this case, 0. So what answer is that? X equals 0. So again, what we're doing here is the exact same thing we did earlier. So it wants a left bound, so go a little left of it, and wants a right bound, a little right of it. And then the calculator's going to find that 0 for you. So then let me do it again for the other part. So I got to find the 2 answers. Let me do it again for here. So second calculator, 0. I want to move all the way to that side. Just keep on moving until you get there. Again, I'd like to actually get to around where the 0 should be. Come on. There it goes. So that's where the zeros kind of should be. So I literally just moved left a couple bit, press the left button a couple of times, hit enter, go back to where I think the zero should be, and hit right a couple of times. Now I hit insertion between with yes, and I get -8. So it had two root solutions, I should say. There they are. If I was going to do this one, right? So a couple ways. You actually graph it this way. You can do y1, y2 and find the intersection, or we can set equal to 0. Do the same way we just did. So -2 minus x. I get x squared minus x minus 22 equals 0. And I could graph it, find the x-intercepts, just like we just did. So that's the first thing I said, equal to 0. Okay, last one we're going to do. So it's an application problem. For exercise 30, use the formula. So we're going to use this formula right here. Where ht, again, when you have a formula, you want to know what each variable represents. H is height, so keep that in mind. H is height. VO is the object's initial velocity, so initial velocity is VO, and T is time. So let's do this example. A baseball is hit with initial velocity of 80 feet per second. So that's my VO. I'm just type that in right now. So my formula is HT equals VO, which is 80, times T minus 16T squared. So that's my equation. Ignoring the height of the baseball player, how long does it take for the ball to hit the ground? So here's the key. Ball to hit the ground. So I want the height to be 0, because that's the ground. And I'm looking for time. I said how long. So I get to my equation here. I'm going to make this equal to 0. Now I'm trying to find when does t equal 0. So remember the way we solve this is by graphing. So I use my calculator, turn it on. Now I'm going to plug this in. I don't have a t, but we're just going to use x. We always just use x here. So 80x minus 16x squared. By the way, in the next lesson we'll learn another way of solving this, but for now all we can do is graph it. So you have that, and we're going to graph it. We're going to learn how to factor next lesson. And I get a graph that looks like this. And I'm going to do the same thing I did before. Second calculator, I'm going to find the 0. That one's 0, I can tell right now, but I'll just do it. Left bound, right bound, yada yada, 0, like I knew. So one answer is 0. That's obviously not the right answer. That's when we hit the ball, so that's not going to count. We've got to find the other one. So let's do second calculator 0. I gotta get all the way over there, so I'm just gonna keep moving it. If you want to go press second, it makes it go faster. And if you're not sure where you're at right now, remember right here it tells you. So this is 1, 2, 3, 4, 5. So if I can move it, there it goes. Right, I'm at 4. I move it, and I'm right here at 5. So that's actually the right bound. So I'm gonna go back. That's the left bound. I'm gonna go a little past it. That's a right bound. I could go further if I want. It switches in between the two, and I get 5. So it takes 5 seconds to hit the ground. There we go.